Hello, friends. Welcome to Hydraulics and Hydraulic Machines class. We have completed 4 units, and now in today's class, we are entering into the final unit of the syllabus Hydraulics and Hydraulic Machines. This final unit consists of pumps. There are again in these 4 parts. 2 parts belong to one type of pumps and the other 2 parts to other types of pumps. What is a pump? Till now, we learned what is a turbine. Now I am asking, what is a pump? A pump is a hydraulic machine which converts mechanical energy to hydraulic energy. Whereas turbine is a hydraulic machine which converts hydraulic energy into mechanical energy. So a pump is just opposite of a turbine in the energy transformation. Once again, a pump actually is a hydraulic machine which converts mechanical energy to hydraulic energy. How the pump will get mechanical energy? A pump is always coupled with a motor. A pump is always coupled with a motor. So electrical energy is supplied to the motor and the motor converts electrical energy into mechanical energy, and that mechanical energy is the input to the pump. Then pump converts that mechanical energy into hydraulic energy. The electrical energy which you are supplying it to the motor is just by switching on in your own house if you do have a pump in your house. So switching on that, thereby you are supplying electrical energy to motor. Motor is converting electrical energy to mechanical energy, and that mechanical energy is the input to the turbine, to the pump, and the pump converts the mechanical energy into hydraulic energy. So hydraulic energy means what? Hydraulic energy is nothing but pressure energy. It is a function of discharge and head. Discharge and head. Head is a representative of the pressure. So hydraulic energy is nothing but the pressure energy which is in the form of or proportional to the discharge and head. So generally we use the pumps actually to lift a liquid from a lower elevation to a higher elevation. That means we are giving some pressure head to that fluid, thereby it is being pumped from a lower level sump. Sump is nothing but where water is stored at the ground level, and or from the well to the overhead tank. Understood? So there what is happening? The mechanical energy is converted into the hydraulic energy. So this is what is a pump means. Now let us go into the topic and then let us see what when we discuss today's class, especially with respect to what are the various types of pumps we have in our curriculum, and out of that what we are taking right now, that we will see. So unit 5, it is basically pumps. Then first, a pump is a hydraulic machine which converts mechanical energy to hydraulic energy. Remember, pump is always coupled with motor. Suppose if we take it, this is the motor, this is the pump. So for the motor, electrical energy is given. This is the input and output is mechanical energy. And pump converts into hydraulic energy. And hydraulic energy means pressure energy. It is a function of the discharge and head. So this is what basically a pump is. The pumps are of two types. One is rotodynamic pumps and the other one is positive displacement pumps. Under hydrodynamic pumps, we deal with centrifugal pumps. Under positive displacement pumps, we deal with reciprocating pumps. Depending on the principle on which a pump works, they are classified either as rotodynamic pumps or positive displacement pumps. So let us start our discussion with the centrifugal pumps. So this is our topic actually in the fifth unit, first topic, centrifugal pumps actually. What is that? Why it is called as a centrifugal pump? If the mechanical energy is converted into pressure energy by means of centrifugal force acting on the liquid, centrifugal centrifugal force acting on the liquid, then the hydraulic machine is called hydraulic machine is called centrifugal pump. Then what is the principle of hydro? The principle of centrifugal pump. The principle of centrifugal pump says that actually it works on the principle of forced vortex. Forced vortex. What is the principle of forced vortex? If a certain mass of liquid is rotated by an external torque, the rise in pressure head of liquid takes place. This is the principle by which. So, this rise in pressure head, the rise in pressure head is proportional to the square of the velocity. It is proportional to square of velocity. And this velocity is the tangential velocity of water, and V is equal to R omega. Therefore, rise in pressure head is proportional to R square omega square by 2G, and omega can be calculated by using 2 pi n by 60. So this is first thing is what is a centrifugal pump, then basically what is the principle of a centrifugal pump. Then we go into classification of centrifugal pumps. Classification of centrifugal pumps. Classification of on the on the basis of the different characteristic features, the centrifugal pumps can be classified based on number one, based on type of casing. What is the casing surrounding it? Based on the casing, it is classified as volute casing, volute pump. When I say volute casing, so it is called as volute pump, vortex pump. Again, these are all in centrifugal pumps only. Vortex pump. Then third one is diffuser pump. So like this, based on the type of the casing that we are using, this can be classified like this. What is number two? Basically, the working head. So based on the working head, it is we classify it as like this. For example, low lift pumps. Low lift pumps. Low lift pumps means less than 15 meters. That is first. Then second one is medium lift pumps. Lift means the height over which the liquid is being raised. Medium lift pumps. It is basically up to 40 meters. That means 15 to 40. Then basically the high lift pumps. greater than 40 meters. This is how, based on the head, we can classify the centrifugal pumps. The third classification is liquid handled. The liquid handled. This is also called as the type of impeller. Impeller is nothing but actually the rotating element of the centrifugal pump is called as the impeller. The rotating element of a turbine is called as a runner. Similarly, like a runner, here the rotating part of a pump, centrifugal pump, is called as impeller. Here I want to draw a small analogy between a runner and impeller. Runner relates to turbine, whereas impeller relates to centrifugal pump. Both are the rotating components only. Number two, here actually, here because of the electrical energy which is supplied to the motor being converted into mechanical energy which is given to the shaft, and the shaft giving it to the impeller will be rotating. Impeller is rotated because of the mechanical energy supplied by from the motor. When the impeller is rotating, the water which comes in contact with the impeller is rotated and thrown out to a larger head. That is the principle of centrifugal pump. In the case of turbine, the water which comes out with certain velocity and pressure head, it strikes the runner and the water jet rotates the runner. Please see the difference. Here, the water jets rotate the runner in the case of turbine. Otherwise, turbine, the energy input for the turbine is the hydraulic energy. When the hydraulic energy is given to the runner starts rotating. Whereas in the case of centrifugal pump, the mechanical energy given to the impeller, because of which the impeller is already rotating actually. When the impeller is already rotating, the liquid which comes in contact with the impeller is rotated and forced to go to higher heights. That is what the principle I mentioned. So this is what we want to know, because when I introduced impeller is like in turbine runner. Here in the centrifugal pump, it is the impeller. Then the impellers are, there are three types. One is closed type impeller. Second one is semi-closed impeller, open impeller. Open impeller is nothing but our fan like. Just if you take it, open impeller is like a fan actually. Whereas for that, if you put the bottom plate, we call it as semi closed. And if you put the top plate also, then it is closed. I have already put the figures actually in the beginning of this lecture. Kindly see it. In the case of open thing, just veins you can see. Whereas in the case of semi closed, the veins are attached to a plate on one side. Whereas in the closed type, on both sides plates are there, the veins are at the center, the openings will be there. So that you can see in the figure. Then coming to the fourth classification, number of impellers. If it is only one impeller, we call it as single stage pump. Single stage pump means one impeller. If it is having more than one impeller, we call it as multi-stage pump. If suppose there are two impellers, two-stage pump, three impellers, three-stage pump, more than one impeller. So that is fourth, last basically. Number of entrances to the impeller. Single entry, that means single suction pipe. Multiple entry, double suction. So last sixth is relative direction of flow. Relative direction of flow through impeller. Relative direction of flow through impeller. So this can be classified as, for example, radial flow pump. Next one is axial flow pump, mixed flow pump. So these are the three things. So finally, I wish to conclude this particular lecture by just making it a centrifugal pump. The flow is radially outwards, typically opposite to Francis turbine. Whereas in the case of Francis turbine, flow enters at the outer periphery and leaves at the center. Now in the centrifugal pump, water enters at the center and leaves at the outer periphery. So exactly opposite. Even the equations also will be of the same nature. Whatever we have used for Francis turbine, just opposite of that we will use it here. I will show you as we move forward into the next lecture. So, in this lecture, I try to give you first what is a pump, what are the types of pumps, and then what is centrifugal pump in particular, what is the principle of centrifugal pump, and how the pumps are being, the centrifugal pumps are being classified. The sixth ways of classification of centrifugal pumps. So with this, I will stop this lecture here. We will go into the components of centrifugal pump in the next lecture. Thank you. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.